Okay, in this problem, we're going to continue where we left off in the other golf ball problem, where we have the same initial velocity, the same angle, but instead of finding the total distance the ball travels, we want to find how high, what's the maximum height that the golf ball goes. Maybe there's some trees in the way or something, and we want to make sure that it goes under that. Or we're just curious. We want to know how high it goes. All right, so to solve this problem, our assumptions are going to be slightly different from the other problem. To illustrate that, I'm going to show what's happening to the ball. So from the original problem, we know that the ball is being launched at a certain angle. It's being hit at an angle of 42 degrees. And after it's hit, due to gravity, it's not going to continue moving in that direction. It's going to actually start to fall, which causes a parabolic trajectory, or a curved path. So I apologize, this 2 doesn't want to write very well. Well, originally we were looking at what is this total distance? And if you recall, we figured out that was 279 meters. Well, now we're not really paying attention to that. We want to know what the maximum height is. So we're interested in this, delta y for that. Well, that means that at the maximum height, we're looking at that point. We're looking where the ball is here, which means we're going to consider that our final placement, not where it lands. So that changes a couple of our assumptions. Delta x is not going to be 279. And if you're guessing, if you guess that it would be half of that, you're actually right. That's not always going to be true. But when an object starts from the ground, ends on the ground, or starts and ends in the same surface, the highest point is going to occur halfway in the middle, which means that the distance is cut in half. It also means the time is cut in half. So those are some assumptions that may help us in the future, though in this problem we really don't even need that much knowledge. This problem is relatively simple once we understand what to do. So now looking at this place, let's evaluate some of our assumptions. Well, we figured out in the other problem, and you can go back to that recording if you really want to, by breaking up my velocity into the two components, we found out that v initial in the y direction was 35.1 meters per second. So that just came from setting up a right triangle with the 52.5 and the 42 degrees. We also always know that acceleration in the y direction is negative 9.81 meters per second squared. There's another assumption, but I want to talk about that in a little bit. In the x direction, we know that the initial velocity from calculating it before was 39.0 meters per second. And we also know that acceleration in the x direction, for simplicity's sake, we're going to consider that it's 0 meters per second squared. It's negligible, which means that it's very, very little, so we can practically ignore it. So now let's look at the x direction. Because it starts and stops at the end place, yes, we actually do know that delta x is going to be half of what we found before, which in this case is 139.5 meters. If we want to use sig figs, really, we should say that that's 140, but that gets problematic because that only has 2 sig figs, so this has to be 1.40 times 10 to the second meters to get those 3 sig figs. But that's not that important. That's not the point of this video. I want to talk about one big assumption in the y direction. So for an object that follows this curvature and it gets to the highest point, we know that up until that point the velocity is positive. After the highest point, the velocity is negative. Well, to go from a positive velocity to a negative velocity, what's in the middle of a positive and negative? The answer is 0. So that means that at the highest point, the velocity, that final velocity at the highest point, is going to be 0 meters per second. If you're not quite sure about that, you can, there's so many videos of cool like roller coaster videos where someone throws up a ball and that ball looks like it's kind of sitting still. What's happening is that highest velocity, and this is actually why when you ride a roller coaster you feel like you're coming out of your seat, is because you for a moment have an velocity of 0 in the y direction, whereas the roller coaster, because it's heavier, actually goes forward and has a negative velocity faster than you do. Anyway, now I'm getting off the problem, but hopefully you get the point that at the tallest point, the highest point, your velocity is 0 for any object. So if you notice, I have 1, 2, 3 bits of information, and I'm looking for a fourth. Well, the maximum height that I'm looking for, height is in the y direction, I'm really looking for delta y. So I have 3 bits of information looking for a fourth. In the one-dimensional motion equations, that's enough. So just to write those equations down really quick, and hopefully some of you recognize what equation you're going to use right away. But the first equation that comes to my mind is the average of the velocities times time is displacement. Then displacement is 1/2 acceleration delta t squared plus v initial times delta t. And then finally, the final velocity is the initial velocity plus acceleration delta t. And final velocity squared is initial velocity squared plus 2a displacement, not time. So now find an equation that has v initial, acceleration, v final, and displacement. Well, that equation is this last one. Remember that delta x is really here one-dimensional delta x. It doesn't necessarily mean horizontal, so we can replace that with delta y. So v final in the y direction squared equals v initial in the y direction squared plus 2 acceleration delta y. So v final, 0. 0 squared is still 0. V initial, 35.1 meters per second. I'm going to not write my units just for simplicity's sake. Plus 2 acceleration, negative 9.81 delta y, what we're looking for. So now you have a simple linear equation. It's linear because this square ends up becoming a number. And if you solve this, you get that delta y equals negative 35.1 squared over 2 times negative 9.81. And you may rearrange it differently than I did. You may have evaluated 35.1 squared first and all that jazz. But hopefully you guys are confident enough in your algebra skills and can follow along at home and get delta y equals 62.8 meters. So this is one of the few problems, if you've noticed, that we could solve entirely in one direction. We didn't have to find a connecting piece like time in one direction and go to the other direction. We actually had enough information in the y direction as long as you knew this part, as long as you knew that the final velocity was 0. With that, the rest is pretty simple. So hopefully you found that simple.